Welcome back. Today we are going to look at subtopic 6.4, which is angles and tangents of circles. But before that, we will look into the second half of what we have learned last week, which is about tangents to circles. Okay, today we are going to look at common tangents to two circles. Most of the tangent that we have right here involve two circles only. So first type that we are going to see is the circles which is separated like these two diagram here, diagram 1 and diagram B. Later on, we are going to look at another three types, which is the circle that is attached together, intersect together, or overlapped. Okay, so here, if the circle is separated like this, then we will have four tangents. So this is 1, 2, 3, 4. Okay, if we have a bigger circle with a smaller one, same thing, we will have four tangents. 1, 2, 3, and 4. Now we look at the second type, whereby the circle is touching each other at one point like this, okay, or attached together. So if you have two circles that attach together like this, you will have three tangents, 1, 2, 3. And then same like this, a bigger and smaller one, you have 1, 2, 3, three tangents. Now we look at the third type, which is the circle intersect together. The circle that is the same size will have two tangents. And then one bigger and smaller one, same thing, we will have two tangents. And the last one is the circle that overlap. Okay, if it overlap, we only have one tangent like this. Okay, now we look at the example that we have in your textbook. This is on page 158. The example 19 here shown, the diagram on the right, with two circles centered at A and B with radius of 4 cm and 3 cm respectively. Given that PQRS, this line here, is a common tangent to both circles, calculate the value of x. So from this diagram here, I'm going to redraw another diagram so that you can see clearer. Okay, we are going to divide this part because we can't find the x like this. We have to separate it into two different shapes, which is a rectangle and a triangle, like this. Okay, so all the value I copied down over here. This is 3. If this is 4 here, this will be 1, 3, and another 1. How do we have that? Because we know, okay, the radius of B, 3 cm, straight away, go to the left. The length or the height is the same, not the length, the width, sorry, the width is the same. So if dimension this is 4, 4 minus 3, this will be 1. And then when you add up the radius of circle, the bigger circle here, this is 4 cm, just like AQ, right? And then if this is 3 radius, B to the tangents over here, or the point that they touch together, is also 3. So 3 plus 4 is a 7. So we will have a 7 over here. Okay, now we look at how to calculate the value of x. Okay, I'm going to write. To get the value of x, you can see we are going to apply the trigonometric ratio, whereby this angle here, the corresponding side is called the adjacent side, right? And then for this one, this is the longest one, this is the hypotenuse, right? So what makes up A and H? That is K, right? Which is cosine. Therefore, we will need to use cosine. Cosine x is equal to 1 over 7. Okay? So therefore, to get the value of x, it will be shift cos 1 over 7, and you will get the value of the angle like this. Okay, cos x is equal to 1 over 7. X is equal to shift cos 1 over 7. Just press your calculator and you get the answer. Okay, now we look at example 20 here. A piece of wood is mounted on a tire as shown in the diagram. It is given that V is a point of contact between the tire and the wood. So your V is here. Okay, W is the point of contact between the wood and the tire. This is a tire, W, wood and a tire. While Y is a point of contact between the wood and the rod. This one. Okay. The diameter of the tire is 50 centimeters, so diameter is 50, which means the radius is 25 centimeter, right? And the distance of WY is 1.2 meter. This one, 1.2 meter for W to Y. Okay, assuming that the rod is a straight line, calculate the distance of VY. So we have to calculate the distance over here. Okay, now I redraw the diagram here into a easier diagram for us to see. Okay, so it will be like this. Okay, WY is 1.2, and then this one is 0.25 because just now they told you the diameter is 50 centimeter, right? So when you convert it to radius, it is 0.25. Now we look at question A. A here, they ask you to find the distance of VY. So you can see the tangent, two tangents that touches the circle, okay? And when you extend the line that meet one point Y over here, they will have the same length. So if this one, WY is 1.2, VY will also be the same. Okay, therefore the answer is 1.2. And then for B, they ask you to find the distance between the center of the tire and the point Y in meter. Okay, between the center of the tire is point O over here and also Y. They ask you to find the length over here. So we know that a tangent that intersect with the radius is 90 degree, right? And you already have 1.2 here. You already have the radius of 0.25. So to find the length over here, we just need to use the Pythagoras theorem. Okay, to get that, this is the hypotenuse, right? So just use the square root of 0.25 squared plus 1.2 squared. Therefore, the answer will be square root of 1.5025, and you will have 1.2257. But the last statement here, they ask you to state your answer correct to 2 decimal places. So if you round off 1.2257 to 2 decimal places, the answer will be 1.23 meter. Okay, now we look at the next slide here on how to solve problem involving angles and tangents to the circles. This is the last example in your textbook. Okay, look at the example here. The diagram on the right shows two pulleys. So we have two pulleys over here, this one, and also a bigger one. Okay, which are suspended from the ceiling BC. This is the ceiling BC. The rope ADO. ADO, this is a rope, connects both pulleys. Calculate the value of x. So we have to calculate the value of x. Now to calculate the value of x, we know that this is the center of the circle, right? So if that's the center, this is the radius, meaning that this is an isosceles triangle. So I mark down here, it is an isosceles triangle. If this is x, this will also be x. So if I want to get the value of x, I just need to look for this. Okay, if you look at this shape here, this is a parallel line, right? Parallel line. If there are parallel lines, so the angle that is in here will be the interior angle. Do you still remember how much is the sum of interior angle? This and this is 180, right? So in order for me to get angle BAD here, I'm going to use 180 minus 108. So the answer here is 72. Therefore, to get the value of x is 180 because the sum of triangle is 180. So minus 72, then you divide by 2, you get the answer of 54 degree. Okay, if you have if you have any more question, you can ask me in Google Classroom. So we finished the chapter already. I hope you understand everything. Okay, I'll see you when school reopen. Yeah, bye.